plus 7 the whole square into y double dash minus 6 into 2x plus 7 into y dash plus 8y equal to 8x. So this is the linear differential equation with variable coefficient. The variable coefficient is the form of ax plus b. Therefore it is Legendre linear equation. So to solve this Legendre linear equation, we have to find we have a method. Okay. So first we have to convert this into standard form. This y double dash is like a d square by dx square. Y dash is the dy by dx. So now I am going to convert it into standard form by changing like this: 2x plus 7 into whole square into d square minus 6 into 2x plus 7 into d plus 8 into y, take y outside, equal to 8x. If you take y outside, 8. So here dy by dx, taking y outside, d by dx. We are took dy by dx is d. Here capital D is d by dx. Okay, now this is the standard form with a variable coefficient 2x plus 7. So Legendre equation. So in the Legendre equation we have to put, it is like x. So 2x plus 7 is like x. So x is equal to e power z, implies z equal to log x. Log x is 2x plus 7 here. Then xd, what is x here? 2x plus 7. So 2x plus 7 into d equal to a into d dash. What is a here? Coefficient of x is a. So 2d dash. Next 2x plus 7 the whole square into d square is, it is 2 square into d dash minus 1. That means this coefficient you have to write 2 square. But here this coefficient is 2. 2 into d dash, here 2 square into d dash minus 1. So finally this is 4, multiply 4 inside. So 4d dash square minus 4d dash. Now I am going to substitute these two values in this equation to convert into constant coefficient. Okay, so this is the term here, which is 4d dash square minus 4d dash. So substitute here. So 4d dash square minus 4d dash minus 6 into 2x plus 7 into d is 2d dash plus 8 into y is equal to 8x. But I want to convert it into in terms of z, because this d dash is d by dz. So I am converting everything in terms of z. So this x also I want to convert in terms of z. So from this, what is x? From this, x is equal to e power z minus 7 by 2. So that x is equal to e power z minus 7. E power z minus 7 by 2. So this is x. Okay, so now I am going to simplify. So now this is 4d dash square. This is 6 into 2, 12. 12 minus 12 minus 4 minus 16d dash plus 8 into y is equal to, cancel this, 4 into e power z minus 7. So now dividing 4. So d dash square minus 4d dash plus 2 into y is equal to e power z minus 7. So now it is as usual differential equation with the constant coefficient. So we can find the solution as usual. So now I am going to find out the auxiliary equation. So what is the auxiliary equation? M square minus 4m minus plus 2 is equal to 0. So I want to factorize this, but I cannot factorize directly. So I am going to use the formula minus b minus, so here what? A is 1, b is minus 4, c is 2. So minus b minus of minus plus 4 minus b plus or minus root of b square minus 4 a c by 2a. A is 1. So now it is 4 plus or minus root of 4 2s are 8. 16 minus 8 is 8 by 2. So this is 4 plus or minus root 8 can be written as 4 into 2. 4 can be written as root 4 can be written as 2. So this is 2 root 2 by 2. So take 2 outside and cancel 2. So 2 plus or minus root 2. You see, this is not a complex root because there is no I. So there are two values for m. One value of m is 2 plus root 2. Another value of m is 2 minus root 2. So there are two values for m, both are unequal. So that I am going to write complementary function formula. Okay, so the complementary function is a in t power m1z plus b in t power m2z. Because we have two different values for m. One is 2 plus root 2, another one is 2 minus root 2. So here I am going to substitute. The complementary function is a into e power m1 2 plus root 2 z plus b into e power 2 minus root 2 z. So this is the complementary function. Next I am going to find out the particular integral, but in the particular integral there are two terms, so that I am going to take particular integral 1 and particular integral 2. Okay, so the particular integral 1, what is particular integral 1? This is particular integral 1, this is particular integral 2. So this is d dash square minus 4d dash plus 2. So I am going to find out the particular integral 1. So 1 by d dash square minus 4d dash plus 2 into e power z. So this is first type. Second type, e power a z. What is the coefficient of z? 1. So here d dash is replaced by coefficient of z 1. So replace here 1 by 1 square 1 minus, substitute 1 here, 1 into 4 4 plus 2 into e power z. So finally 1, this is plus 3 minus 4, 1 minus 1 into 1 by minus 1 into e power z. So which implies that minus e power z. So this is particular integral 1. Next I am going to find out the particular integral 2. pi2 1 by d dash square minus 4d dash plus 2 into, the second term is minus 7. So that minus 7. So this term can be written as e power 0 z, because every term can be written as multiple of 1, that 1 is e power 0 z. So that d dash is replaced by coefficient of z 0. So that 1 by 0 minus 0 plus 2 into minus 7. So finally the particular integral 2 is minus 7 by 2. So we found particular integral 1 and particular integral 2. So the solution is y is equal to cf plus pi1 plus pi2. So finally the solution y is equal to a into e power 2 plus root 2 z plus b into e power 2 minus root 2 z, and the particular integral 1 is minus e power z, and the particular integral 2 is minus 7 by 2, where z equal to log of 2x plus 7. So this is the solution of the given differential equation.